This is going to be our last video for adding and subtracting rational expressions. We're going to go ahead and just apply what we've learned in factoring binomials and just finding the LCD and adding and subtracting our rational expressions. So here's our last examples. What we're going to do first is we're going to take a look at the order of our denominator in our first example and make sure that we're in the right order. So we are in descending order. We have our x squared, our x, and then our constant in both of them, so we don't need to switch our orders. So the next step is then to find our LCD. Well, we can't find our LCD unless we factor. So let's factor the denominator of our first fraction, and then we'll factor the denominator of our second fraction. So we know when we factor we're going to get this. And what are the factors of 72 that add to 17? You know it's 8 and 9. So those are factors for our first rational expression and our second rational expression. What are our factors of 56 that add to 15? And we know that's going to be 8 and 7. Okay. So let's walk down our factors and find our unique factors and build our LCD. So the first factor that I see is x plus 8, and I have an x plus 8 in both. So x plus 8 is in my LCD. The next factor that I see is an x plus 9. So that's part of my LCD. And my last unique factor is x plus 7. So that's part of my LCD, x plus 7. So compare the factors of our denominator in our first term. We have an x plus 8 and an x plus 9 to the factors of our LCD, and we can clearly see that we're missing the x plus 7. So we're going to multiply our very first rational term by x plus 7 over x plus 7. And we're going to multiply our second one. We have an x plus 8 and an x plus 7. So we're missing the x plus 9. So we're going to multiply our second term by x plus 9 over x plus 9. Okay, so the next step is just to multiply out our numerators. So we're going to distribute this x across both of those terms, so we get an x squared plus a 7x over x plus 7, x plus 8, x plus 9. And we're going to subtract from that. We're going to take our 1 and distribute. We don't really need to distribute a 1, but we have an x plus 9. Okay, so here is where parentheses become really important, or else you're going to get your answer wrong every time. Alright, so I said previously that we should always have parentheses around binomials or trinomials that are in our numerator or denominator. So I'm putting my parentheses around here. Once I do that, I am then going to combine into one fraction. I'm going to leave my parentheses around. With addition, it's not so important. But with subtraction, it is really important that you do this. Okay, we have an x plus 7, x plus 8, and an x plus 9. Alright, so now what we're going to do is we're going to distribute. If we did not put parentheses around, we would forget to distribute this negative. Make sure you don't forget to distribute that negative. Once I do that, my parentheses can go away. And now all I have to do is simplify the numerator and see if it factors. So now I have an x squared plus 6x plus 9, and I can see that that definitely factors. I'm not going to write the whole thing out here because I don't really have enough room, so I'm going to move down here and factor my numerator into an x plus 3 times x plus 3. Your teacher may want you to rewrite that as x plus 3 squared. The last step is to check and see if any of the factors in the numerator reduce with any of the factors in the denominator, and you can clearly see that they share no common factors, so they don't reduce. This is our final answer. Okay, so if you need to write down the work, go ahead and write it down, because I'm now going to erase most of it so I can fit in my next example. Okay, so in my next example, I want you to notice that our denominators are not factored, so let's go ahead and factor it. The first one is a binomial, so we should check and see if we have one of our special binomial factors. And we do. This is a perfect square, and the other one is a perfect square. So I'm going to do this one in a different color. Perfect square and a perfect square, so this factors into x plus 3 and x minus 3. Because our a, if we take the square root of x squared, we get x, so a is x. The square root of 9 is 3, so b is 3. Our second term here, our denominator factors into an x minus 3 and an x plus 2. The factors of negative 6 that add to negative 1 are negative 3 and positive 2. Okay, so our LCD, let's figure out what our LCD is going to be. Let's walk down and see what our unique factors are. I have an x plus 3, and it's the only one that I have, so that's part of my LCD. I have an x minus 3 in both terms, so x minus 3 is part of my LCD. And then I have an x plus 2, and I have used up all my unique factors. So we are ready to go. So we are going to multiply the first term here. We're missing, out of the first term, we have an x plus 3 and an x minus 3. We're missing the x plus 2. So we're going to take that x plus 2 and multiply the numerator and denominator by it. And so I'm going to leave this in factored form. And I'm going to add to it. What is missing from our second one? We're missing an x plus 3 from our second one. So we're going to multiply the numerator and the denominator by x plus 3. And again, I'm leaving the bottom in factored form. We should always do that. So let's go ahead and multiply out. So when I distribute this 3 across both terms, I get a 3x plus 6 over my LCD. X plus 3, x minus 3, x plus 2. And when I distribute across this, I get a 2x plus 6, and I get an x plus 3, x minus 3, x plus 2. Okay, so let's see what happens. We need to combine our final terms. So we end up with, I'm going to move this over here, we end up with a 5x plus 12, which is prime, it does not factor, x plus 3, x minus 3, x plus 2. Okay, so our final answer is 5x plus 12 over the LCD.